Okie dokie, here we go. Happy Game of Thrones week. Snow day and April week coming up on Thursday. And the Bulldogs are going to be in the Frozen Four on Thursday, so should be a good day. All right. Familiar topics, should be anyway. Sine, cosine, tangent, Pythagorean theorem, so we'll just jump right in. If you're going to use these, we have to talk about which sides are which. We need to know some terminology. So the hypotenuse, opposite, and adjacent sides are terms you need to know as far as working with this right triangle trig. The hypotenuse is always opposite of the 90. So here's a 90-degree angle. It's the biggest angle in a right triangle. And so the hypotenuse is the longest side, always opposite of that. The opposite side is the one that's opposite the angle we're using. So if I'm using this angle right here, the opposite side is this one, and that leaves the adjacent side, which is the one next to the angle. See, this one makes up the angle as your adjacent side. If I move the angle and now I'm working with this angle down here, that's going to switch which two sides? The adjacent and the opposite. Now this one's the opposite over here, and this one's the adjacent over there. The hypotenuse is always opposite the 90, so that one's always that one, across from the 90. Okay? So what we're going to do now is we're going to talk about what is the sine, cosine, and tangent values. So what is sine? What is it? What is the sine? You said opposite over hypotenuse, right? So what is like the sine of, I don't know, any angle, right, is equal to the opposite over the hypotenuse. And I guess if I were just trying to explain, what is the sine to you, right? It's a ratio, like you said. It's the opposite side divided by the hypotenuse side in any right triangle. And what that does is that creates a value. You can have it as a fraction, like a ratio, or you can reduce that fraction, or not reduce, but approximate it to be a decimal. And so there's a whole table of values here that highlight all of the different possible sine values, right? So there's the sine of 0 degrees right there is 0. Sine of 1 is 0.0174. Sine of 2, sine of 3, all the way down. And these values keep getting bigger and bigger and bigger as you get closer and closer to the sine of 90 degrees, which then ends up being 1. So it's really a value. The sine of some angle is a value between 0 and 1. Okay, whether you represent it as a ratio or a decimal or, well, I guess that's pretty much it, but it's a value between 0 and 1. Okay, what if you had, like, why is the sine, let's just think about this. I can't move that around anymore. Stupid. Why is the sine of, 1 degree, why is the sine of 1 degree 0.0174? Like, why is it so small? Because 1 degree is so tiny. What is a right angle? What does a right triangle with a 1 degree angle even look like? Let's just sketch that. This is going to be, okay. There's a little wee one there. Whoa. Actually, I could do better than this because I'm on my smartboard. I can make lines. Okay. This is going to be a hard part right here. Come on, you little turkey. God. This thing should, can't we make an angled line? Stupid board. It's not smart. Won't even let you do an angle. There, it kind of does. Oh my God, what a joke. This video's trash. Alright, so I would have been better off freehanding that. Anyway, so what if I tried to make a 1 degree, 89 degree, 90 degree triangle? It'd be like, you know, I mean, it's hard to do, but there's a 90 right there. This angle up here is 89. And then this one over here is a 1 degree. So what is the opposite over hypotenuse of 1 degree? Well, opposite of 1 degree is this wee little side right there, and the hypotenuse is this not so wee side right there. And so when you divide wee by not so wee, you get basically 0, right? So as this angle 1 increases, then the sine values increase. Something else I want to talk about is if you remember from geometry, similar triangles, so they're triangles that have all the same angles, so they're the same shape. So because this, like sine and cosine and tangent values, they're the same no matter what size triangle you have. So if I make a triangle that's like, whoa, super wee. Oh my God. Suck. This is a 1 degree angle right there. That's a 90 over there. And that's my smartboard is tweaking out right there. It did a bump. But anyway, so like this is 89 degrees there. So the opposite we divided by the hypotenuse, even if it's a smaller triangle, excuse me. Wow. Like small. Oh, a wee little side. So this wee little side here, this opposite side's small, and this hypotenuse over there is a little bigger. It's the same. So no matter what you look at, I think my smartboard's freaking out. Watch, I'm going to draw a straight line, but it's going to go for a bump. Nope. Nope, that was me. That was me. All right, let's get back on track here. So if we go back to this here, 30 degrees is the most friendly value for sine and cosine. Well, sine actually. 30 degrees for sine gives you exactly 1/2. And if you remember from geometry, remember special triangles, 30, 60, 90s? It was like 1, 1/2, and then root 3, root 2, or 1, 2, and all that. So that is part of this whole thing, is like, take a look up here, 30 degrees gives you a sine value of 1/2. It's the most, like the cleanest value for sine or cosine. So anyway, every 30 degree angle, the opposite side divided by the hypotenuse always equals 1/2, no matter how big or how small the triangle is. Right? If I have another one, like let's just say I have this is 3, okay? If that's 3, this has to be 6. Just has to be, and that's 30 degrees. So every time, no matter what, no matter how big or how small the triangle is, the sine of 30 degrees is always equal to 0.5 or 1/2. Okay, so all sine is a ratio of opposite side divided by hypotenuse. Okay, if it was 15 degrees, you'd say the sine of 15 degrees, what is that equal to? Sine of 15 degrees is equal to, in this case, 1.29 divided by 5. And 1.29 divided by 5, if I type that in my calculator, I should get 0.2588. Okay, every time, no matter how big or how small that is. And so, like in Mr. Bolio, 1998 grad, 9th grader. So what would that be? 1994 or something. When I learned this, we would have to look up this table of values in the back of the book, just like this, and you'd have to look it up, and you go, okay, well, the sine of 15 degrees is 0.2588, and then you type that in your calculator and you go from there. Okay, now we just typically use calculators and type the whole thing in. All right, let's keep moving along here. Talk about cosine. Cosine. Same concept, but now it's adjacent over hypotenuse. That's the CAH. Cosine is adjacent over hypotenuse. So in this case, the adjacent side divided by the hypotenuse, 10.39 divided by 12 should be equal to, if you look it up, this is the cosine table of values, and the cosine of 30 degrees should be equal to 0.866. So if you take 10.39 divided by 12, you should get 0.866. So because we know all these different values for sine and cosine and tangent, we can use those values to solve in equations when we have missing unknown sides or angles. Okay. Same concept for tangent, except for tangent is the opposite divided by adjacent. Notice the tangent values go from like very small all the way over here to like large, and even as large as infinity. Right? And that's because if you took if you took a triangle like we were just sketching, right? Like, all right, let's try this. 90 degrees. What's the smallest angle I can put in a right triangle that's not 90 degrees? 1. Okay. What's the next biggest angle? 89 or 89.9999999, right? So if I put an 89.999 degree angle in there, that's essentially 90, but it's just slightly slanted to the left. These are going to intersect somewhere in outer space, right? Does that make sense? Somewhere up in the atmosphere, they'll intersect. And if you do the tangent of that really small value, that really small angle up in outer space right there, you're going to be doing the opposite side divided by the adjacent side. And it's basically like taking super small number divided by a super large number, and you're basically getting 0, right? If you do the opposite of that, and you say you take the tangent of 89.9 degrees, now we're making this side here the opposite, and this side here the adjacent. And now we're taking a really big number. Wait a minute, what was I doing here? Opposite TOA. I screwed up, didn't I? Anyway, you're taking a really big number. So like, let's say you had the tangent of 89 degrees would be the opposite, divided by the adjacent. Duh, I'm being dumb right now. So then you'd be taking a big number, like super big number all the way to outer space, divided by like a really, really, really small number, and you're going to get almost basically an infinitely large number, which is why when you look at the tangents, when you get down to like 89 degrees and 90 degrees, the values for tangent are getting really, really, really big. Like it says infinite in the table, because at 90 it keeps going forever. But you can't have a 90-90. You can't have two 90 degrees in a triangle because it won't meet, right? You could have an 89.9 and a 90, and then they would meet like way up in outer space somewhere, in reference to the drawing that I had on the previous page. Are you still with me, or are you sleeping yet? Okay. So tangent is opposite over adjacent, and that's why you see some values that are more than 1. In fact, 1 is the tipping point at 45 degrees. Why is a tangent of 45 degrees 1? Well, what do you know about 45-degree angles? These are the same, right? Like so 6, 6, and then this would be, if you remember geometry, 6 root 2. So if you did, say you had a 45-degree angle, what is the opposite divided by the adjacent in every 45-degree angle? It's always 1, because it's an isosceles triangle. Those sides are the same. So tangent's a little different. You get a value of 1 at 45, and then it starts getting bigger and bigger and bigger and bigger and bigger and bigger all the way to infinity. If you go the other direction, it gets smaller and smaller and smaller and smaller all the way almost to 0 on the other end. Anyway, so long story short, what is the sine, cosine, and tangents? What are they? They're just ratios. SOH and the sine, cosine, and tangents, they're just ratios. They're sides in a triangle that are divided, right? And for sine and cosine, it produces a number between 0 and 1. And for tangent, it produces a number that could be between 0 and infinity. Okay, let's show you how to use them again. So first thing you got to figure out is what sides do you have, so you can figure which ratio to use. So in this case, I have the hypotenuse, and I also have the opposite. So, no, it's not TOA. So the question now is it sine, cosine, or tangent? Which one? And that's where you use the whole SOH CAH TOA bit. So that's sine, the one with S, sine uses OH. The one with C, cosine uses AH. The one with T, tangent uses OA. So we have OH, so we're going to use the one with S, which is the sine. So set this up. Sine of the angle, which is 26 degrees, is equal to 5 over x. Okay. The hypotenuse is on the bottom. The last number in the saying, or the last letter in the saying SOH CAH TOA is always the one on the bottom. So it's the H, and the A are the ones on the bottom of the ratio, the denominator. So now what are we actually doing here? I'm just going to show you a little old school with the table. Sine of 26 degrees. We talked about that as being a value. Sine of 26 degrees, if I look this up on my chart, is 0.4384. So really what we're doing is we're saying the sine of 26 degrees, which is the same as 0.4384, right, is equal to 5 divided by what number? So if you just think about this and kind of think about it as an estimation for a minute, 5 divided by what number do you think is about 0.4384? If you had to guess, what would you guess? What was the guess? You remember from last hour, you little turkey. He said 11, and that's a pretty good guess, I think. 5. Someone last hour said like 9. And then I was like, well, 5 divided by 9, that's like more than 0.5, isn't it? 5 divided by 10 is 0.5, and that's still too big. So we'd maybe do 5 divided by 11, and that might be a little closer. So I'm thinking x is going to be somewhere around 11 probably. Okay, now how do we be more specific than that? Well, I like to just set up a proportion. So make that over 1 and use your cross product property. So cross products are going to be equal. So I take sine of 26 times x and set that equal to the other cross product, which is going to be 5 times 1. And so now I can get x by itself by dividing both sides by the sine of 26, because the sine of 26 is just a number. It's 0.4384. So this might as well say 0.4384x. But that would be an estimation, so we just keep it as the sine of 26. So those puppies cancel out, and I'm left with x is equal to, what is it? 11.41. Okay, which is about what we thought it would be. Okay. Do a couple more. Let's do one with, let's see, what do we have here? That's the adjacent, and that one is the, wait, what are we talking about? The hypotenuse? Yep. I usually start with the hypotenuse, and then I go to the opposite, and then I go to the adjacent. So in my mind, I go like this. Okay, I have H, O is that one, and A is over here at that one. Okay, I don't really care about the O because I have nothing by there, so I'm using the one with A and H. So which one has A and H? Is it sine, cosine, or tangent? It is going to be the cosine. Why? Because that one is the CAH. That one is the one with the A and H. So now I set up that ratio to be the cosine of 64 degrees is equal to A over H, which is x over 42. Now I make that a proportion and I just use my cross products. In this case, when the variable's in top, you end up multiplying. In the previous example, the variable was in the bottom and we end up dividing. So anyway, we have x times 1 is x equal to 42 times the cosine of 64 degrees, and you can just type it right in the calculator like that and make sure it's in degree mode. And you should, your calculator, is it in degree mode? There's a button on there. You should all know where the degree mode and radian mode button is on their calculator. Yeah, yours is in degree mode. So you should get 42 times a cosine of 64, whatever that is. Cosine 64, 18.41. That makes sense? Does that look about right? Does that make common sense with what our picture says or should say? I think so. Okay, the last one here, same thing, but which function do you think this one's going to be? Which ratio do you think we're going to use on this one? Probably tangent, because we haven't seen that one yet. So let's see, we got our H is right there, our O is right there, our A is right there. Which one don't I care about? The H. Great, we're going to have this stupid game. They're always after me, Lucky Charms. Okay, so we have O and A. That's going to be sine, cosine, or tangent. That one's going to be the tangent. Why? Because it's TOA. It's the one with O and the A. The one with the O and the A is TOA, the tangent. Set up the tangent function. Tangent function, activate. Tangent of 18 degrees is equal to. Remember, the tangent of 18 degrees is just some value. It's stored. We could look it up in the table of values if we want. Okay, it's probably like, I don't know, point something. Tangent of 45 is where it tips over at 1. So anything less than the tangent of 45 is going to be like between 0 and 1. Between 45 and 90, that's where they get to be bigger than 1. Anywho, so what do we get here? Tangent of 18 equals 12 over x. We got the variable in the bottom, so we're going to end up dividing to solve. Make it into a proportion, set your cross products up. X times the tangent of 18 degrees is equal to 12. Divide both sides by the tangent of 18 degrees. And those cancel out. Yeah! And you're left with 36.9. 36.93 degrees. No, not degrees. It's a measure of length. Pick it up what I'm putting down out there. Any questions? You could use a table of values, right? But you'd still have to divide a decimal or something. We're getting to that. Okay. So on the next page, I'll show you how to find an angle. So when you're finding an angle, now we are kind of working backwards a little bit. So let's just say, in reference to angle X, this is the opposite side, and this one here is the hypotenuse. And so which ratio uses the O and the H? The sine, that's the SOH. Okay, so now I have the sine of, now I don't know the angle, so it's X. is equal to 10 over 13. So now I have to like work backwards, okay? If this was old school Mr. Bolio in the 90s, I would have done 10 divided by 13 on the calculator on a simple one and got 0.77. So where is the sine value equal to about 0.77? And then I'd go back to my table and I would look up, instead of I wouldn't look at the angles, I'd look at 0.77 and I'd go, haha, there it is. It's probably like 51 degrees about. But that was the old school, like without a fancy calculator way. So now we have calculators that have all this information that is, just stored on the calculator. So now you want the calculator to look up what angle goes with 10 divided by 13. I know, she's falling asleep. I used to do it all the time. You're fighting it. Shake it out. Okay, there you go. All right, we're almost done here, and then you can run around. So, how do you type that in? Here's what you do. This is what Chris was saying. Sine inverse, that little -1 thingy. When you do the little sine -1, what that does is that looks up, hey, what angle goes with this ratio? And like algebraically, you can think of the inverse sine of the sine as kind of canceling each other out. So now you just have x equals the inverse sine of 10/13, and that will look up in your value what angle that goes with. So inverse sine, I got to use parentheses on my TI-85, the most superior of the TI line. 50.28 degrees. Haha. Inverse sine, and then 10/13. It's usually the second button and then the sine key. So you have to find it on your calculator, wherever your sine is. Yeah, see it in yellow? So then put second. Yep, hit the yellow button and then the sine button. Yeah. I never said anything about a sig dig. You just wanted to sound cool and say sig dig, didn't you? I just want to make sure you're comfortable over there. Are you comfortable? Okay, right. Your feet aren't falling asleep? Imagine if Jada was like that. She'd be sleeping by now. She would have fallen out of her chair by now. 28 minutes. Oh my gosh, this is taking forever. I'm gonna get ripped on for this. Okay, so opposite over adjacent, I believe. This one is TOA, isn't it? So you want to find the angle here. You're gonna have to do the inverse tangent of O over A, which is 4/9. It's as simple as that. Boom. So figure out what ratio to use. Put the inverse tangent, cosine or sine, and then put your O over A or your O over H. And then you type it in, and that'll give you your angle. 23 point who? All right, 23.9 about. Duh. Grease. Okay, duh, bears. And then the last one here, same thing, but different function. We're getting kind of redundant here. This is going to be A. That's going to be the H. So if I want to do that, that's going to be cosine. So that's going to be the cosine inverse of 74 over 103. You know what happens in your calculator if you put 103 over 74? What is your calculator going to say? It's going to say error. It's going to say undefined or something like that because you screwed up. So a good tip is if if it ever says error or something like that, it's probably a good indication if you're using SOH CAH TOA that something's upside down. Okay. So this one, Aaron, would be 44.1 degrees. Okay, last thing I'll say, don't forget about Pythagorean theorem. I left the work on this one already, so you don't have to write it out. If you have a problem where you have to find a missing side and you're given two sides, right? Like sometimes students will just get fixated on what we learned last and they'll forget about other stuff that they learned a long time ago, like Pythagorean theorem. So in this case, you might not be able to solve every problem with SOH CAH TOA because you don't have enough information. In this case, we have a problem where we know the hypotenuse and we know one of the sides and we want to find the other side. Okay, we don't know any angles. So you can't use SOH CAH TOA unless you were to find an angle first, and then you would just be doing two problems instead of just one. So nope, you can't use angle 90 because the sine of 90 is going to be 1. Doesn't get you anything. Because look at, if you use this as your angle, as your theta, then your opposite and your hypotenuse would be the same thing. Know what I mean? Yeah. So anyway, don't forget about Pythagorean theorem. It still works. And if you have two sides and you need to find the other one, you can go ahead and do that. All of this stuff, SOH CAH TOA, Pythagorean theorem, only works for right triangles. Okay? All right, so that is just over 30 minutes of pure boredom. So sorry about that. At least it's nice out today.